Today I have the pleasure to introduce you to our dear speaker, that is John Kipton. John is our risk consultant based in our Kenya office, and he has over 9 years of experience in operational risk mitigation. And before joining NetGuardians, he had several positions at Citibank, such as Head of Operations and Technology Operational Risk, Head of Information Security. And without further ado, I let our dear speaker, John Kipton, continue with his presentation. Please don't hesitate to ask your questions anytime. I wish you a happy webinar. John, the floor is yours.
Thank you, Mine. Hi, you can hear me clearly?
Yes, we can hear you, John.
Great. Thank you very much for the kind introductions, Mine. For the participants, I'd like to welcome you to our continuing series, our webinar series. Today, our discussion is fighting digital banking frauds using machine learning. We look at some benefits and practical examples, and I hope this will be impactful in your day-to-day task as a risk manager or an IT manager or whichever role you play in your bank. Now, our agenda is divided into 5 parts. We look at some quantum just to give us a sobering view about exactly what's going on and what's going to happen in the future. We look at some challenges, and I'm sure you're pretty familiar with some of this because you're basically there on a day-to-day basis. We look at how NetGuardians is, going to help you manage some of this risk using machine learning. Really, this is the way forward. I'll do a small demonstration just to be able to give you an idea of exactly what you should be looking forward to in case you're wondering how this works. And we'll leave out some 15 minutes at the end for a Q&A so that we can also be able to interact with you and hear out your concerns, your questions, and we'll try and answer as many as we can in that portion. However, for those that will not be able to answer, we'll be able to do an email thereafter to just respond to you so that we shall leave no stone unturned. So our quantum is just to give us an idea about what we are working on in terms of the cost of this fraud from reputable sources. For example, Cybercrime Ventures in 2016, 2 years back, projected cybercrime to be a $6 trillion business. And I'm sure this has gone up based on what we are already seeing with the SWIFT fraud and so on. According to KPMG, in 1 year, cybercrime or cybercrime fraud increased by over 1,000%. Fraud losses in the UK in 2017, according to the Financial Fraud Action UK, this is the group, sector working group, purely focused on this area of fraud, and I would always urge you to bounce all your ideas through this group. 2017, they lost $1 billion. And the reason is simple. The world is going digital. There's a lot of digital channels. Banks are faced with all these challenges, to cut the expenses, and of course they're now innovating. There's a lot of fintech companies also pushing the agenda, and that comes with a lot of new cyber fraud challenges. Banks are focused more on efficiencies in transaction processing, timeliness, and so on, but they forget some aspects of risk and security. And what banks have previously used is rule-based solutions. Coming from the old days of AML and auditing, now we should be moving more towards daily risk management. And if you're using a rule-based solution, I'm sure you can attest that it's no longer risk management. It's more, ticking off tasks that today I've looked at this area, I received a number of alerts, I've looked at them, etc. And that leads to a lot of false positives as well as false negatives, meaning that frauds have gone through and they have not been caught. What is making this cybercrime a big concern is that it's no longer being just done by small-time criminals. It's now an organized business. In your countries, you will have a lot of this already. You can see in the news. If you look at Kabanak, kind of, Trojan, etc., we now have governments involved in cybercrime. As you can probably see from the news, they are very much focused, to be able to make money in the most, in the wrong ways. Now, some of these challenges and what I've just been referring to, what you're seeing online, $81 million lost through cyber crime, through the SWIFT network, and this was Bangladesh Central Bank. Potential loss was $1 billion, and you can imagine the kind of money $1 billion is. So if you're a bank, if you make $100, $200 million in profit every year, that's your 5-year business going down the drain. So you can imagine that sometimes you might think that you're not losing too much money when you look at your expenses, operational risk losses. But what happens when you have one event that wipes out $81 million from your books? And this is a direct hit on the P&L. This is a very sobering view, and it gives you an idea as to exactly what can go wrong. Okay, you might even be forced to restate your accounts. You'll invite, regulators will start to have a deeper look. It's not a very comforting situation. We have other examples of, the Retefe saga in Switzerland and Austria, and this has now, breached borders, especially in countries where internet banking is the preferred mode of banking. As you can see, the transaction behavior is very different in various geographies in the world. But for those geographies, especially in Central Europe, where you have a lot of e-banking sessions, customers like to use e-banking to do transactions. We have Retefe that is redirecting these sessions to a fake website, and they capture your login credentials or your session information, go ahead to hijack the session, and do as many transactions as they can in that short period when the session is still alive. Okay, but Switzerland and Austria are mostly affected, and this has been ongoing for about 4 years. However, has now gone on to very many other countries. Social engineering is one of the biggest threats. It is coming up in the agenda of all central banks, the agenda of all fraud, anti-fraud working groups, be it in Southern Africa, be it in Europe, be it in Asia, UK, etc. Social engineering risk is the top of the agenda in all these areas, and therefore, by default, it becomes part of your agenda. BBC estimates $1 billion as a result of social engineering, money lost. According to the FBI, over 2,000% rise in social engineering fraud. So it's becoming, you're talking about phishing, you're talking about all sorts of, cyber crime as well, happens through a lot of social engineering and so on and so forth. This kind of statistics give you an idea. On your right there is some BBC News article where somebody lost $12,000 in a SIM swap fraud, of course, again through social engineering. In Kenya, for example, mobile banking and M-Pesa has been a revolution, payment revolution in Kenya, and it's catching up all over the world. For example, in Asia, it's estimated that in Thailand and Malaysia, mobile is set to become the dominant mobile banking channel for consumers in how they interact with their banks. So this is coming. In Kenya, the loss last year was just 17 billion, and then mobile phones were at the center of all this. Okay. And how is that being done? Through what you call the SIM swap fraud. Here is some 2 articles, and there's a lot of information online that you can catch on this. If, for example, I look at this SIM swap, it cost about 884,000 rand lost for a retired couple. You can imagine this is taking back their 20 years out of their life savings. And they're able to access your mobile banking by basically switching your SIM card at the provider, and suddenly your phone is inaccessible, and all you see later are transactions that have already occurred. They even go ahead to do virtual lending. There's a lot of virtual lending products across the world. They go ahead to take loans on your behalf. So these are examples in which your customers are affected, and when such things happen, they will obviously complain, through social media. And that is why this operational risk, the biggest concern with operational risk, apart from the fraud loss, is the reputational risk that you face as an institution, because this will all be, a lot of this information will be shared online and so on and so forth. In terms of risk mitigation challenges, so, we've already put into context what are these kind of issues we are facing. There's a lot of internet banking fraud through, for example, the RTF issue. There's a lot of SIM swap through the mobile banking channel. There's a lot of as well of card fraud on both the credit and the debit side business. A lot to do with card not present or counterfeit, for that matter, for debit cards. So you've seen the kind of issues we are facing. It's cybercrime issues that are first-line breaches on a bank. It is social engineering, where they are now accessing the customers directly, or even accessing the bank staff. If you look at the Bangladesh Central Bank fraud, the fraudsters were able to access the internal network using a particular method. This is the Kabanak, which is now spread across 14 countries. They have defrauded over $1 billion, and they're able to access internal accounts. They're able to inflate balances and move money out of the bank through now these digital channels we're talking about. So this thing is real. So some of these challenges that banks face, I just mentioned a bit at the start, is because as much as you're innovating, as much as you're making the life of your consumers and customers very easy in terms of transaction and how they interact with the bank, in terms of risk management, how are you able to look at all these transactions that are coming through the channels? And there are so many transactions. It's in the millions of transactions. Mostly using legacy rule-based system. For example, what you see here on the screen, you'll have a rule to say if a payment destination is in a country, for example Russia, or high-risk AML jurisdictions, payment is greater than $10,000, then flag that transaction for review. In real sense, when you look at that rule, there's nothing wrong with that with a payment going to Russia of greater than $10,000. It could be a legitimate transaction. So what that means is that you'll have so many rules or so many outcomes, so many events that you need to review, which means you'll have to hire an army of guys, to be able to review all those. At the end of the day, you'll find that one or two transactions will be fraudulent or may raise suspicious, needs further look. And that's the reason why we are saying it's no longer possible or tenable to have such an army of people to review a lot of hits, but without any value or reducing the bottom line in terms of fraud losses, which will in terms of operationalization of an institution, it is not practical. Okay. Now, when you apply that rule, and you say, I'm looking at transactions above $10,000. So what about the transactions that are below $10,000? And you'll find that maybe when you look at your transaction profile of your customers, maybe most of your customers are doing transactions of $1,000, $2,000. So which means that all those customers, you're not reviewing their transactions. So there's a big portion. When you put it collectively, you'll probably find that transactions below 10,000 form 80% of your transaction volume. So you're basically looking at 20% transaction volume or by value, because volume will be more on the bottom scale, lesser on the higher scale, but you're looking at high value transactions. But collectively, at the end of the day, by value, most of the transactions are below 10,000. So it means there's a lot of exposure that you're not looking at, and that is why senior management boards will always be asking, how comes we have a risk department? How comes you have an audit department? How comes you have invested in a system? It's rule-based. Why are we still experiencing fraud? That's a difficult question, and it's just a question where now a different approach needs to happen. And this is where, as net guardians, we come in and provide a solution, because the way the world is going, there's a lot of digital information, there's a lot of digital footprints, whether it's on your mobile phone, which gives you access to the, creating hundreds and thousands and hundreds of thousands of, digital footprint across, your digital profile. So it could be Facebook, you could be on your Twitter, you could be doing transactions. So everything has basically gone digital, and banks are not being left behind. And the only way forward is to move away from the rule-based approach. You have now to go into machine learning. And the essence of machine learning is to say that I will understand every individual and understand the habit of each individual on their own. Because no two individuals are the same. You might be similar, but you cannot be the same. And that difference is what machine learning is trying to, bring out. That I want to understand person A differently from person B, so that if a transaction comes in from person A, then I'll be able to differentiate and say that based on their previous transaction profile, based on their past behavior, based on everything that I have seen and that I can touch, this transaction does not match the behavior of person A, and therefore I will raise an alert, I will raise a hit, so that this particular hit can be reviewed independently of all other transactions in the bank. And you can see this is completely fundamentally different from what you used to use before, where you'd cluster everybody, in a rule of, let's say, I'm reviewing transactions above $10,000. And of course, as your behavior changes, I mean, you might be in a different station of life now. You might have a better job in the future. You might open a business and you're moving money around. Then your profile will change, and that's what machine learning as well is doing. It's just every time you do a transaction, it is coming into your profile, it is being updated, it is dynamic, and has to be in real time. Okay, so and that is the essence in which we come on board with our solution. In the next slide, we can see that our approach is moving away from the traditional, what I've already introduced, where you have one rule that is created for each individual fraud type. So this is what you probably may be referred as supervised learning, that the rule is created for past incidences. But fraudsters are not waiting for that. They are also creating ways in which to beat the system. They're very much aware about your internal processes. They're very much aware about your internal controls. So any action they take will be to beat those systems. Because probably those rules and controls are only designed to address what is known. Now the question is, what else? And that is a question that the traditional approach cannot answer. Now, the only way the traditional approach will try and answer is by creating more rules, by creating more audit cycles, and make them very frequent, and create a lot of acrimony as you're doing all these audits, calling for information, having countless meetings. But at the end of the day, still at the end of the year, you hear that there's $81 million lost through a SWIFT fraud. So you ask yourself, is this really the approach? So the Net Guardian's approach is now moving away from that. Not to say that we will stop it altogether, because for some of these rules, we also need to to have an approach which combines both traditional and proactive. The proactive way is the Net Guardian's way, where we are doing machine learning, where we are detecting a fraud, bringing it back into the model, making the model better, understanding who the customer is. Any transaction that comes in is compared against that particular customer and all their transaction profile. If there's anything out of the ordinary, it is raised as a concern so that somebody can be able to look at it. Now, what this means is that new fraud is being caught every time it happens, because now it's becoming unsupervised. The model itself is learning, it is building, it is understanding, it is looking at what other frauds are taking place in other customers, and therefore is able to add that into part of the rules, and in itself is catching all this fraud automatically. So if you give an example, if a particular fraud is uncovered where the beneficiary is a particular account, it basically means that in all future transactions, if there is a transaction where the beneficiary is a particular account number, because that beneficiary account in a particular bank is already known to be fraudulent, it means then you should be able to stop those kind of transactions. Okay, and that is the learning process that is taking place. As well as to increase your operational effectiveness, because the number of hits that you're reviewing are now less, and more likely than not, the kind of hits you'll be reviewing will be very close to either suspicious, or if not suspicious or it's not fraudulent, then that information is passed back into the model to ensure that in the future such kind of hits will not be, will not be brought out, because the previous model has confirmed that these are not particular suspicious events, and that is the advantage. And better, with time, the model becomes better. With more information, it becomes smarter, and with time, now you're able to actually address the real issues. Now, in terms of real time, because these transactions, customers, banks have offered real-time transaction channels, and therefore, in terms of fighting fraud, you cannot say that you'll be doing this intraday or end of day as you wait for a dump of your transaction of your transactions. And NetGuardians is able to do this in real time. If, for example, somebody does phone takeover by a SIM swap, we will see, for example, that the email number has changed. Now, if the email number has changed in itself, as an item or as a variable, does not create or does not raise an alarm. It is unusual, but somebody could have changed their phone. But we also look at other particular, variables. For example, what you see here at number 3, in terms of computation, all those are variables. About 15 of them that we have in our model for picking out all these unusual transactions. So if the email number has changed, that is the identifier to the physical device, the phone, or the IP address, or whatever else that we can use to identify a physical device that is used to generate a transaction. Then we look at other transaction attributes. Are you doing this transaction at the usual day or time that you're used to? Are you sending it to the usual beneficiary that you send this information to? If it is internet banking, it's the same question. Who are you sending this money to? Is it to these high-risk countries? You combine all those in a model. Number 4 there, what you call the risk scoring process. So you're putting all these variables together and you're weighting them to give you a score to tell you between 0 and 100 whether this transaction for. When I put all these variables together, when I weigh them, when I compare them against your previous profile, let's say it comes to 70%, then what are these variables that are causing this transaction to show me that it's 70%, and so on. And the model only picks particular attributes so that we are also understanding the past and also planning for the future. So in this particular, what you see on the screen here, you are picking an amount, you're picking a location, you're picking a counterparty, you're picking a currency. It's because you've understood that some of these transactions follow certain method. So if a fraudster takes over your account, the amount will be high, trying to hit the ceiling. The counterparty will be new. There'll probably be, if it's a RTFA, somebody has taken over your session, hijacked your session. You can see particular public IPs may have changed. You can see now you're doing a dollar transaction. Usually you do, Swiss franc transaction or whichever currency you're using. So these particular events, for us to be able to build this model, it means you have to understand your fraud cases. So I would urge you, the listeners on the call, that your fraud register has to be accurate, has to be up to date, and has to have all the pertinent details of a transaction. Because when I come in and I want to understand how do the frauds take place, we have to be able to first stop what's going on, as the model in itself will learn and stop for you other coming frauds. Once you understand that this particular transaction is high risk, because the score is at 85 or it's at 90%, then the question is, should we block that transaction? Essentially is to say we are now moving from detection to prevention. If it is between 70 and 80, what action should we take? Should we freeze that transaction and call the customer, and so on and so forth? So those are some of the decisions as an institution you take. Because once the model tells you that the risk score of this particular transaction is 90%, then what action should follow? Should we order that payment for investigation? Should we approve it? Or should we totally block anything that follows through in that account? Because it could be a case of account takeover after identity theft has taken place. And based on our case study for some of the customers we've interacted and moved them from the traditional approach to this preventive forward-looking approach using machine learning, we are seeing that the number of false positives, suppose you used to review 1,000 hits every day, or 1,000 hits were produced from the previous traditional approach, that you're looking at a reduction in 83%. So you have lesser and lesser hits to review, You have lesser and lesser time wasted looking at transactions that are legitimate, calling customers, and some of those customers start to see that you actually keep on calling them for the same kind of thing. They get pissed off. They will raise those concerns. And our detection rate is now at 118%, meaning that we are now catching the previous frauds because we've understood based on your fraud data, your fraud register, what you've been keeping, in the past, we've been able to stop those kind of, frauds going forward. And also the model is picking up new ones. And that is why it's over 100%, because we are now catching newer frauds that were not yet being detected before. And this is actually very good for a lot of banks that I have seen, is that now you're able to justify, the investment, that you're able to catch what has been going on and also what is coming in. So as I'm closing, we know that digitization does not only creates opportunities for banks, but it also gives impetus to the fraudsters. So we have to be able to do a proper risk assessment before you deploy the digital channel. I think this is one of the biggest weaknesses I've seen with a number of institutions, is that they're quick to launch, quick to market out there. The fraudsters are happy to receive such news. If you have not done a fraud risk assessment on those channels, definitely you will see an upsurge in your fraud losses because the fraudsters are very organized. They have mules, a lot of university students looking to make some small money, as much as it's an illegal way. They're happy to receive, pass the money, and take their cuts. The only way forward, as I've stated, is through machine learning. And that reduces your false positives, increases your fraud detection rate, reduces your false negatives, which means now you're catching more frauds. And in terms of return on investment, it is probably estimated that in less than 1 year, you should be able to be catching more fraud once you deploy our solution. So Mine, I will hand over to the Q&A in case there are any questions coming from the floor. I can take one or two. Thank you.
Thank you, John. Thank you very much for the presentation. Really interesting. So now we have some time left to receive some questions. Please don't hesitate to ask your questions. Meanwhile, during the webinar, we have received a few of them, so I would like to start with some of these questions, John. And yes, one question is about the cross-channel fraud. Could you explain a bit if NetGuardians is able to fight cross-channel fraud, and how does it work?
Thank you, Mine. In terms of fighting cross-channel fraud, I'll just go to one of the slides. What you see here is a model, and the model is capturing information from, as you can see here, the blue is denoting for you the IT layer. So if somebody in the back end, through, for example, the Kabanak, Trojan, was able to inflate a balance through a database insertion, then that is happening at the IT layer. Then NetGuardians is able to pick for you, for example, that somebody has gone to the database and has done an update of a transaction variable, for example, the account balance. That information will be correlated with transaction now going through the channel, because now the money has to be cleaned through the channel. The channel is inside, is the amount, for example, that is leaving the bank. So you can see that this particular customer, they're used to doing this particular amount, but today they're doing a high value amount. When you look at the transaction information, for example, you can see that when you look at all the attributes, for example, this is mainly through the session information that you receive, that an IP address has changed for this particular customer because their account has been taken over. So this is one example in which now you have to apply cross-channel, picking information from various sources. So what NetGuardians does in this particular screen, at point 1, it collects information on the e-channel. A lot of session information sits on the channel. Let me just highlight that for you. A lot of information sits in the channel, especially session. So I was speaking about email number or IP address of this particular e-banking session, or it could be the POS that normally you've never transacted in a POS in a particular country. You might be picking from the IT layer, because you're saying a lot of these Trojans, a lot of cyber crime starts with somebody hacking and accessing your core banking information or the back end of your systems, and somebody is altering, for example, balances. And at the transaction layer, you can see that transaction information of the particular customer account. So this is the core banking we are talking about. And this is how Mine, as net guardians, were able to pick in all particular activities affecting all these 3 areas. And at the end of the day, we can, out of the 15 variables that I've shown in the model that is used to calculate the risk score, it comes up with all particular, from all these particular areas. Thank you.
Great, John. And we have one more question about the implementation process and also the licensing model. What is the licensing model used to implement the solution? Could you tell us more about the business model and implementation process also in general? We have also other questions regarding the implementation process.
Okay, so we have a fully fledged, implementation team at Net Guardians, made up of a lot of former bankers, so they understand a lot of core banking systems. They understand a lot to do with integration at the channel layer, digital channels. So they come again with a lot of experience in, for example, Postillion. You have FlexCube, we have T24 experts. So implementation cycle is really shortened because we're able to give you a lot of, we have experience in those areas. Implementation typically, for example, if you want to monitor the IT layer, a lot of back-end actions, typically it takes less than a month to deploy, which gives you a lot of comfort, a lot of oversight about what IT administrators are doing from the back-end. If Trojans take over, through spear phishing, takes over an IT administration session, and they're now being able to, inflate balances. All this is happening at the IT layer. What usually takes place is that in a month, NetGuardians is able to tell you all these typical activities that are happening at the back, whether somebody is editing, deleting, dropping a table, exporting large sets of information, which is very popular for card fraud because fraudsters usually download all the card details and are selling them on the dark web and so on. So typically it takes a month. For other particular areas, we spend a lot of time, especially on the digital channel fraud, fine-tuning of the model, because this model has to be, bringing you results that are 95% confidence. So that usually takes a lot of, quite some time in terms of fine-tuning, where the risk consultant will sit with your business team and identify and say, are all these hits something close to what we are seeing? So that the model, as the model is learning, you're also giving it as much intelligence as possible so that it can be able to arrive at its own decision. In terms of pricing, there's quite a lot of information that we require from you. For example, count of transactions, the digital channels, how do we integrate, and so on and so forth. So pricing is not, one fit size all. It could be a large bank, it could be a medium bank, but mostly we reach out to our customers who are interested. So for example, for the person who has posed that question, Mine will be happy to get back to them and understand some of these intricate details so that we can give them something that is, something very close to what is real. Thank you.
Thank you, John. And are banks able to customize their own risk models?
So far, NetGuardians has, because we have a data scientist team working very closely with universities in Switzerland to build these models based on behavioral analytics. We've already created about 4 to 5 models to capture both digital channels as well as insider fraud. So these models, as we can see, and we've deployed across many customers, they are already taking customers at 80% prevention. Yes, you can modify, you can create your own model, but so far what we've customized and is ready to deploy, what is customized and ready to run, it's already sorting out customers in a big way. So we've not seen customers exactly who want to modify their own model. Remember that with machine learning, let's show you quickly. Yes, with machine learning in this, let me just annotate for you. The beauty is you don't have to involve yourself and to try and create all these models. There's a lot of machine learning going on here. There's a lot of model improvement, which is self-improvement. So there's very little time you need going forward, but during the initial stage, during the initial project, there's a lot that we need to do in terms of behavior, understanding your transaction, mapping up your clients, and then we let now the analytics take over. So in terms of creating your own models as a customer, you don't need that. The system will take care of a lot of improvement, detection, and machine learning. Thank you.
Thanks, John. I think we can just take one more question. There's one question about cybercrime attacks. Like, is NetGuardian also preventing cybercrime attacks, like hacking attacks, or is it something that we are not positioned with our solution? Could you please talk a bit also about this aspect?
Yes. So in terms of cybercrime, NetGuardian does not offer you a cybercrime solution. However, we have teams partners that we work with to offer that kind of, for example, if somebody is sending you phishing emails, or somebody has installed a keylogger on your network that is capturing the passwords of internal users or staff that are either involved in processing or IT admin credentials, that we do not cover that area. However, the modus operandi of a fraudster is that once he has accessed through this a Trojan or a keylogger, once they're able to capture some of this information and inflate some of these balances, that is when NetGuardian is waiting for you. So if you try and edit a table, a transaction table, or change somebody's password, we are able to identify for you that. If somebody is trying to do transactions that are outside the profile of a particular customer, we're able to capture that. So the first line defense will be, SIM tools to be able to capture this cybercrime or day zero attacks. At that point, that is mostly covered by SIM. We have partners, we don't do that. Where we come in is where we have to look at actions of users, actions of customers through looking at their transaction profile or looking at the activities of internal staff. So yes, the two, cybercrime and fraud, work hand in hand. However, for cybercrime, that is not our part. We are very much focused on the fraud, the transaction, and the user activity. Thank you.
Great, thanks a lot, John. Unfortunately, we are running out of time now. There are a few questions left unanswered. We are sorry that we don't have any more time, but we will get back to you by email. So you can always, if you have any remaining questions, send us an email and we will get back to you with explanation, and we'll be happy to also talk to you. So we thank you all for joining us today. You joined us from different countries. We had participants from Asia, Europe, Africa, really from all around. So if you have any questions, if you'd like to learn more, please don't hesitate, and we will send you the recording together with the slides very shortly. So I thank you all for attending this webinar, and thank you very much, John. Do you have a few last words to say?
For me, I think I hope I have been able to articulate myself, but I am very much, as you can see on the screen, there are the contacts. You can always reach us on these numbers. You have my email there. You can go to LinkedIn as well. You can, search, and we can always, have discussion. So feel free to reach out. I'm very much, in a position to be able to have further discussion with you. So I think, Mine, that's all from me. Thank you.
Thank you very much. Have a nice day all. Bye-bye.
Bye-bye.